Before we get into hypothesis testing for proportions, I want to do a quick review on the sampling distribution of a sample proportion, just because we are going to be using this information throughout the hypothesis testing process. So as a reminder, p hat is our sample proportion, and it is found by taking x and dividing that by n. X is the number of individuals, of individuals with the desired trait or characteristics. And N is our sample size. So if I take a sample of 200 people and I want to know what's the proportion of them that have blue eyes, I would count up how many people have blue eyes, divide that by the sample size, and whatever I get, that's my sample proportion. And you leave it as a decimal. Do not turn proportions into percentages unless told to do so. Leave proportions as decimals. Do it. Okay? The mean of the distribution is equal to the population proportion, P. And remember, it's really important, don't get P and P hat confused. These are the two that tend to get confused the most because they are so similar. But the sample proportion is the one with the fancy little hat. And then the standard deviation is the square root of p times 1 minus p divided by n. And again, notice these are p's, not p hat in that formula. Our central limit theorem, now this is different than the one from the book. I prefer that you guys use this one, but I think that number is wrong. I apologize. This should be 5. Is n times p times 1 minus p is greater than or equal to 5. Part of the reason why I prefer this one is it's a little more restrictive. It's not as conservative as the ones that you would find if you look in your textbook. Another reason is it's only one formula to check. You only have to do one thing. Your textbook gives you 2 different ones and you have to check both of them, and they both would have to be true. So if you've looked at your book and you've used the ones from your book, I'd really prefer that you use this one. It does work out the same, but this is just a whole lot easier. So anyways, and then our z-score formula for proportions. So our z-score formula is p hat minus p divided by that standard deviation formula. So square root of p times 1 minus p over n. Couple of things that I saw. The square root is only on the bottom part, but it's under that entire bottom part, but it doesn't cover that top part. And remember, we want to do the top and the bottom separately, but we don't want to round our z-score calculation until we get to the z-score itself. So when you're doing that bottom piece, keep all the decimals that you get until you do that division, and then you can go ahead and round your z-score to 4 decimals. Yeah. So that's our sampling distribution for our sample proportions. We're going to use a lot of this information in our hypothesis test.